just look up 1.41 in the chart, and that will give you the same area. It'll just give you the area on the other side. It'll give you the area between 0 and 1.41. It'll give you this, which is the same. So for this part right here, just go to the chart and look up 1.41, and it'll give you that area that you want. Because whether it's on the left side or the right side, it doesn't matter. So let's go there and let's look up 1.41. It is 0.4207. So your answer is going to be 0.5, which is all the area on the right, plus 0.4207, which is the more slim amount of area on the left. So take 0.5 plus 0.4207, and you get I'm assuming it's 0.9207. Or you could write it as 92.07%. It's up to you. So that's how you do that one. So hopefully you're starting to see that the chart only gives you a limited slice of info. So you have to use your knowledge and you have to kind of improvise and just figure out what works for each question. And in this case, 92.07% is a pretty reasonable answer, because it's, as you can see from the chart, or from the graph, it's a lot of area right there. And another thing that's important is make sure that your answer is always positive, because these are areas that you're figuring out and they represent probabilities. So area is always positive and a probability is always positive. So you'll always have a positive answer. So hopefully everyone's good with that one. And now let's go to the last one and see what that one looks like. What is the likelihood of selecting a sample between, and then you have two values right there. And one of them is below the average and one is above. Okay, so let's do that one. So again, let's just reestablish all of the info that you need. So mu is 110,000. Sigma is 40,000. And then n is 50. So this is 1D, except I'll slightly alter it. Okay, so let's do two different values. So instead of 100,000 and 112,000, let's do 98,000 and 113,000. Again, just because I don't want to give away the exact answer for everyone. Okay, so we want to figure out the area between these two values. So take each of them and convert them to a z-score, and then you'll figure out what's the area between those two z-scores. So, as per usual, same formula, x bar minus mu over sigma divided by square root of n. So plug everything in. So for the first one, we'll do 98,000. So that's the first one. X bar equals 98,000. And then you'll have to do a separate second one for the other one. Yeah, because I think for a lot of people here, they'd be tempted to plug both of those averages in and to find only one z-score for them, but that's not what you do. Every x bar average corresponds to its own distinct z-score. So in this case, since you have two of them, you'll have two z-scores at the end. So for the first one, let's do 98,000 minus 110,000 divided by 40,000 over the square root of 50. Now you can kind of anticipate what this is going to look like, because 98,000 is below the average of 110,000, so it'll be a negative z-score. And it'll be a pretty large negative z-score because it's pretty far below the average. Okay, so on the top, let's do 98,000 divided by 110,000. That's minus 12,000 divided by 40,000 over the square root of 50. So everyone go in their calculator, type in minus 12,000, hit divide, hit bracket, hit 40,000, hit divide, hit square root, hit 50, and then end the bracket, and then hit equals. So you get minus 2.1213. So let's round that to minus 2. Sorry, my writing is messy. Minus 2.12. So that is your Z-score corresponding with 98,000. So put that to the side. Actually, here on the top, let's write that. Let's write minus 2.12, just so we have that right here.